in power electronics lecture number 5, we'll start with the numerical number 1. So in this numerical number 1, a converter is shown. Now what is this converter? We have to identify. So let's say what is at the input side? V mains. So that's a AC. And at the output side, it's a converter involving a transformer and a half wave. It's a half wave rectifier, right? So it's a AC to DC converter. So the converter shown above has a purely resistive load. What do you mean by purely resistive? Fully resistive load, right? And the value of it is given as 1 ohm and the delay angle is pi by 2. What is pi by 2 in degrees? 90 degrees, right? Delay angle is same as firing angle. So we have to find out rectification efficiency. What do you call what is the rectification symbol? Like this. Then power factor, form factor, ripple factor, TUF and PIV. So we have to find all these things. What is TUF? Transformer utilization factor. And then we have to find the PIV rating of T1. What is T1? SER. Alright? Any doubts related to question? So shall we start? Yeah. VRMS is given or VM is given? VM. And remember, VM sin omega t over here, in this case, is the secondary voltage. This is secondary voltage. That is something called as secondary and primary, that you know, right? So secondary voltage is VM sin omega t. Remember that. Okay, so let us start with the solution. So first of all, we are supposed to find the value of average value of the output, right? So let us start. V out average or VDC. What is the formula? Vm by 2 pi into 1 plus cos alpha. So please find out this. VDC will be, what is Vm? 100 divided by 2 pi into 1 plus, what is delay angle? Here you will write 90 degrees. So please find out this answer. Sorry? It's given directly, PMS 100. So cos 90 is basically 0 if you check. Correct? Cos 90 if you substitute in a calculator, that will be 0. So 100 upon 2 pi is the answer. So what is it? Is that fine? Are you all getting 15.915? Yeah, that's correct. So that is my VDC. Next, we have to find I out average. I out average, which is called as IDC. Yeah, correct. But which V out? V out RMS or V out average? V out average or VDC upon R. So that will be 15.915. What is R? So what is the current? 15.915 amperes is the current IDC. Going along, can I proceed, right? Now next we have to find V out RMS. What is the formula V out RMS? Vm by 2 1 minus pi, alpha upon pi plus the whole raised to 10. So here we'll substitute 1 by 1. Here 100 divided by 2 into 1 minus, what is alpha given as? 90 degree pi by 2 it है. So here you substitute pi by 2 only, right? Plus sine. What is 2 alpha? Alpha is 90, so 2 alpha will be 180. What is sine 180? I think it's 0. Sine 180 is 0. What will be the answer? This will be 50 into 1 minus half, right? The pi and pi will get cancelled. Raised to half. That will be 50 into 0.5 raised to half. How much is that? How much is that? 50 into 30? Yeah. Yeah, correct. 35.35? Yeah, that's the answer which you get. V out RMS. Next, once we get the value of V out RMS, did you get, everyone got this? Yeah. Once we get this V out RMS, we have to find out power factor. So let's find out power factor. What is the formula for power factor? Yes. How much is V out RMS? 35.35. How much is V in RMS? Yes, exactly. So here additionally I am writing something which you can note it down, especially in case where transformer is given. So basically we have to find out the RMS voltage. We have to find out the RMS voltage of transformer secondary. We have to find out the RMS voltage of transformer secondary. So what is that? Vm by, that will be 100 divided by, which is 70.71. Let's check. Is it? Yes or no? So this is nothing but V in RMS. We substitute it over here. So how much is power factor? Is it correct? Yes, it is in the range 0 to 1. If it is anything above or below 0, then you have to recheck the previous step. Next, we have to find, is the speed okay? Am I going too fast? You all are following? Yeah. Sorry? Next, we will find rectification efficiency. This is denoted by this symbol. What is the formula? PDC upon PAC into 100. So what is PDC? PDC into IDC. Both the values we have found out. Then what is PAC? V out RMS into I out RMS. Correct? So let's find out this. What is VDC? 15.915. And what is IDC? 15.915. Remember? Same. So multiply this and get the answer. And what is V out RMS? Actually, we can write it as, I out RMS. It will be V out RMS upon R. So this will be nothing but V out square RMS divided by R. What is 15.915 square? 5? Yeah. And how much is PAC? What is V out RMS? I think 35.35, right? 35.35 square, what is R? 1. So find out what is PAC. 35.35 the whole square. Sorry? ये इधर PDC में गड़बड़ है थोड़ा ना. What is wrong? It's not volt, it's watts, it's power. So this is how much? 1, 2? Approximately we can approximate because it is 1000 के ऊपर. So decimal point only 1 is sufficient. Now what will be efficiency? Rectification efficiency. PDC upon PAC into 100. 253. Write it down please along. Write along. Divided by 1249.6 into 100. How much is this? Efficiency will be between 0 to 100. If we get anything above 100, that is wrong. 20.6. Okay? So that's the rectification efficiency. Next, this is a 10 marks numerical. Next is form factor. Form factor, what is the formula? P out RMS divided by, yesterday only we wrote, upon VDC. We have both the values, right? Just plug in. P out RMS is 35.35. VDC is 15.915. Just calculate this. Yeah, it's 2.22. Form factor. Next is ripple factor. RF. What is the formula? Form factor square minus 1 raised to half. You check your yesterday's notes, it's written there. So it will be 2.22 square minus 1 raised to half. How much is that? Is it 1.98? Yeah, correct. It's 1.982. Everyone getting are in sync? Anyone getting different answer? Let me know immediately. Okay. What is next? TUF. Right? Transformer utilization factor. What is the formula? PDC divided by VS into IF. Your VS is nothing but your secondary voltage. So VS is nothing but V in RMS. And what about IS? IS is same as I in RMS. And what is I in RMS? Let's go back to the circuit. They build a current remains same throughout, right? Can I say this current over here flowing? This current I in RMS is same as current flowing to the SCR is same as I out RMS because series है ना तीनों. Current is same, right? So I can write it down as IS is equal to I in RMS is equal to I out RMS, correct? And what is I out RMS? Is it correct? Yeah? Because current in the loop is same. So please substitute these values. So TUF will be PD P value is 253.287 divided by, what is V in RMS? 70.71. What is V out RMS? 35.35 divided by 1. R is 1, right? So calculate this PUF. How much is this? 0.1 what? 1014? Fine. I am getting 1014. Fine. So this is TUF. Did you get it? Now next is last PIV rating. PIV rating of SCR. Now PIV rating of this SCR, which is the T1, is basically VM. PIV rating of SCR is basically VM. What is PIV rating? Rating the maximum reverse voltage across the SCR that SCR can handle when it is in the reverse blocking mode. Is called as PIV rating. Yesterday I have explained you what is PIV rating. So what is VM? 100. Peak inverse voltage. This completes numerical number 1 for today, and very, very important. Similarly for half wave, full wave also we have similar kind of numerical. Pretty straightforward. Only two things we have to know. V out RMS, V out average, that's it. Rest everything will come as it is according to the formulas. Fine. So we'll now solve a different variety of numerical. I will not solve any two numericals same. If it is same, I'll give it for you all to solve it. Next, numerical number 2. Write down this numerical number 2, entire statement. This is a solved numerical from P.S. Bindra, 4th edition book, example number 6.1. A single phase 230 volt, listen carefully, please concentrate. Yeah, please concentrate or else you will miss out on what information is given. A single phase 230 volt 1 kilowatt heater. All of you are using geysers at home, right? That's what, that's heating the water, right? So here we have a single phase 230 volt 1 kilowatt heater is connected across single phase 230 volt 50 hertz supply through an SCR. मतलब हमारा load क्या है? What is my load? Heater. Heater is my load. So for the firing angle delay of 45 degree and 90 degree, calculate the power absorbed by the heater element or in the heater element. So normally in your household you use single phase supply. So they are saying by using a single phase supply you are controlling the heater, right? And that is a 230 volt 1 kilowatt. तो बोलो ये resistive किधर है? We will find out ना. Normally heater is a resistive element. First, note down the numerical. It's completely different from what we have solved up till now. This is solved example in Bimbra 6.1. You can check it out. Okay, shall we start? Okay, if I tell that heater is a resistive element, I should know its resistance, right? So write down first step, heater resistance. Anyone can tell me what could be the formula of heater resistance? Okay, now tell me one thing. What is the formula for power if it is a resistive load? Power So what will be R? Now you tell me what will be the heater resistance now. So what is voltage? How many volts heater it is? So it will be 230 square divided by how much is the power? What is 1 kilowatt? 1000 watts. So 230 square divided by 1000 watts is my heater resistance. How much it is? Yeah, correct. So heater resistance is 52.9 ohms. So this is my resistor basically. Everyone following how we converted how heater is a resistive element and how to find that resistance? Okay, now it is pretty straightforward. So let me know, let us rewrite the formula for V out RMS. What is it? Again, guys, into 1 minus okay. This is for half wave control rectifier with resistive load. It will not work for any other. If it is a RL load, the formula will be different. Now what they have asked, let us understand. They have asked us to calculate the power absorbed in the heater element. But what is the power absorbed in the heater element? Power absorbed will be V out square divided by R. मतलब हम लोग को V out RMS चाहिए ना, divided by R. For alpha equal to 45 and alpha equal to 90. So first we'll consider for 45 degree, calculate V out RMS. We'll do V out RMS square divided by R. That will be power absorbed by the heater. Is it clear? Straightforward step. So let us write it down together. First, for alpha equal to 45 degrees, what do you mean by 45 degrees? How will you convert into radians? Into pi divided by 180. So how much it is? What is pi by 4 in number? No. 45 degrees in number, exactly pi by 2. 0 point radians. Write it down. Or you can directly substitute here also, no problem. 785, right? Here you can substitute pi by 4 directly in place of alpha. Okay. Now, what will be Vm? Achha, what is Vm? What is this 230 supply? Yes. So, V in RMS is how much given? So, what will be Vm? What will be Vm? 30. Let's keep it as 230 root 2 only. We'll calculate it together. Now, let's calculate V out RMS. It will be 230 root 2 divided by 2 into 1 minus, what is alpha? Pi by 4 divided by pi plus sine. What is alpha? 45, right? So it will be sine 90 divided by 2 pi. The whole raised to half. Please calculate this V out RMS. This will be 1 by 4. Sorry? 1? Yeah, that's the correct answer. 155.08. I'll wait for some time. Did you all get 155.08? 5.08, 0.07 nearby that. Everyone please solve individually using your own calculator. Okay, so next statement will be power absorbed by heater element. Power absorbed by heater element for alpha equal to 45 degrees. What is the formula? V out RMS divided by R. So that will be 155. Yeah. V out RMS square divided by R. So R is how much? 50.9. Calculate the power absorbed by the heater element. 450 watts, right? Now similarly calculate for 90 degrees. Same procedure. These are the answers. Power absorbed, are you getting similar? Don't just write a value. Please verify it using a calculator. Ultimately, you have to write it in the exam. Yeah, clear? So we'll solve the next part. That is for alpha equal to 90 degrees. This much we have completed. So next will be third part for alpha equal to 90 degrees. What is 90 degrees? Pi by 2 radians. And over here Vm will be 30 root. So we have to calculate V out RMS at alpha equal to 90 degrees. That will be Vm by minus pi upon alpha plus sine 2 alpha upon 2 pi. The whole raised to half. Vm is 230 root 2. Sine of 180 degree divided by 2 pi. I think sine 180 is 0, right? Calculate this, how much it is? volts, correct? So what will be the power absorbed? V out RMS square divided by R, 115 square divided by 52.9. Approximately the exact 250. Yeah, that is 250. 250 watts. This is a 5 marks numerical, not 10. Okay, completed. Now I will give you one numerical for home support. You can do that at home because it's a similar numerical and it's a solved numerical from Bimra. You can check your answers from there also, right? And after that, we'll immediately start with the test. So everyone completed up till here. So that will be all for today's lecture. But I will give one numerical. You write it down. That is one. Numerical number 3, home support numerical. You will complete it at home. It's example 6.5 from PS Bimra 4th edition. It's a solved numerical. So numerical goes as follows. A single phase transformer with a secondary voltage of 230 volts, 50 hertz delivers power to a load, 10 ohms load, through a half wave controlled rectifier circuit. So for a firing angle delay of 60 degrees, determine the following. So for a firing angle delay of 60 degrees, determine the following. Again, it's a 10 marks numerical. Okay? Determine power factor first, second rectification efficiency, third form factor, then voltage ripple factor, TUF and PIV rating of SCR. Haven't we solved similar numerical? So please solve this and cross check your answers with that solved example. That you can search. Okay, so with this, let us start with the test now.